Digital twins, they are perfect labs for experimentation. They mirror real-life complexities and allows us to safely mess around with scenarios and become playgrounds for all our what-ifs. What if there is a war? What if inflation rates doubles? What if there's another pandemic? And how might the global economy endure these shocks? And how can we build resilience into our financial models? That's on top of Craig's agenda. And he works with the World Bank and local central banks on using the foresight that comes with digital twin simulation for the purpose of strategic innovation. And it seems to me like even the tech is working. Not bad. Give him a very warm welcome.
Hello. Am I on? Yeah. All right. So, thank you, everyone. I'm actually going to start my timer. I've got quite a bit to get through today. But just to compliment the intersection group, I've been fascinated over the last 2 days. I've learned so much from you. This is always the lousy part about kind of going towards the end, because you're like, oh, look at that, I've discovered this, I've brought this, let me bring this in. And suddenly your presentation goes to 500 slides, and you have to cull it down again. So just thanks to all the speakers, and the many conversations I've had outside have been really, really super exciting. So I want to take you on a little bit of a journey today, and look at this, the Mac is actually working. I was like sweating bricks because the Macs haven't been working. And so there's 3 stages I'm going to work you through, and you're going to see me putting my glasses on and off because I'm those 55-year-old eyes are letting me down now. All right, but there's the first phase we're going to work through. I'm going to just have a little bit of PowerPoint, and I need to move through this pretty quickly. These will be available for you guys afterwards, but I'm going to move quite fast through them. They're quite visual. Second phase is I'm actually going to do a very high-level digital twin system dynamics conversation using a system dynamics model, just so you understand some of the basics around competing objectives. And then I'm going to go into a fairly sophisticated model, which was done for preventing financial contagion, and we'll talk a little around how these models can be used for big fourth-order type problems that we would normally see in central banking, those types of environments. Okay? That's our journey. Now, I came across this little piece some time ago, and I thought it was pretty relevant because what it does is it looks at the economic life cycle, which is red, sorry, the boom and bust cycle, as well as the stock cycle. In other words, the amount of assets under management. And you can sort of see, as we head up this boom and bust cycle, the key takeout from this is look at how many different disciplines and models and things we are doing to deal with complexity. And there's no shortage of these things. There's no shortage of new models, new methods, new frameworks for us to use because we are trying to deal with complexity. And so, lots to work through. There's been a shift at a business level. No longer do we just innovate at the bottom. We have to start innovating further and further and further up the cycle. So we can't just innovate around products. We have to create innovative operating models, innovative business models, and look to re-engineer an entire ecosystem in order to create and capture new forms of value. So there's a requirement for us as enterprise and strategic designers to be able to deal with higher and higher levels of complexity. Well, what is complexity? And this is a fairly famous model, all right, slightly tweaked for a particular message I want to convey. But a lot of what's occurring now is sitting in that complex space. So complicated is I want to build a Rolls-Royce Boeing engine. We know how to do it. There's sufficient people around who can help me. And so there's a solution. Problem's well known. But the design discipline is very much in this complex space. This unknown problems area, which means we don't actually know what the problem is. We can't really do root cause analysis and connect these things together, right? And there's no known solutions that we're aware of. And being able to answer those types of questions is a key set of criteria that you want to work through in order to understand, should we use design or some other discipline to tackle this problem? But this is still all about complexity. Design Systems thinking, those types of things, are all about trying to deal with that section in the middle there referred to as complexity. And that complexity doesn't have to be climate change, all right? Organizational design is still extremely complex, and so also fits into that complexity space. And so we need to learn to be comfortable with the complexity area. So these are Richard Buchanan's 4 orders of design. And starting from the bottom up to the top, nice pictures, beautiful objects, great services, big ecosystems and systems. So we operate predominantly in that top section. It means that we still use all the underlying sections underneath, right? But we are trying to understand the system and the system dynamics and how all of the components of that system work together to help you achieve the outcome. And what we find in the digital twin space is when you hear this word digital twin, you think some form of visual representation of a building or a steam engine or a car that you can kind of play with and have a look at. Yes, there is that bit, but it's second order. We operate on digital twinning at the 4th order. And I've kind of called it a digital twin because it's very, very close to mimicking the behaviors of what occur within a business. Right? And I'll explain the differences just now. So I'm going to demonstrate stuff for you that sits up at that 4th order level. And same story here. Some of the projects we're involved with really go right up to the top into that ecosystem space. So complexity is increasing. Right? I'm currently working on a project that has got to connect 3 different countries, Kazakhstan, Azerbaijan, and Georgia. All the agencies in those projects, all the public and private companies in that entity, and try and get them to work together as a system to optimize traffic from China to Europe. Talk about a complex situation with all of the cultural and bureaucracy and sort of things that sits behind that. So there's layers that we work at, and most of the things that we do as enterprise and strategic designers is fractal. It can occur up at that top layer, it can also occur in the bottom layer. All right, good for time. All right, so not to get into arguments because there's different ways, but everyone loves a good Venn diagram. Okay? No presentation's whole without it, but those are the disciplines that we bring together. So there's the dynamics of systems thinking, but then there's also social dynamics. How do we bring in the human element into how that affects the system and the behavior of the system? All right? And so how do we do that via design thinking, and how do we also bring in futures, cause and effect relationship, signals and trends, scenarios, flags on those scenarios, what's more likely to come true versus not, what's the impact going to be on your business? Well, in order for you to answer that question, you need to understand what the impact on the business is going to be. You need to have a digital twin where you can test ideas and concepts on that business model. I'm going to skip over that. So one of the areas that and sorry, you can't see that, but you'll see it in the presentation. So this is what we refer to as systems-oriented design. This is the playbook we created for the World Bank to think at a systems level. And today, I don't have the pointer on me, there in the middle there, just under the word define, and here at the bottom, just under the word develop, there are what are referred to as system dynamics models that allow us to create and manage the behavior of the system and test ideas and concepts on that system to see how does it work together. And that's what we're going to talk about today, and we'll have a few demonstrations on that. Okay. So just to give you some idea of the types of problems I've had the privilege of being involved with, all right, some fairly big, complex scenarios to be able to navigate. And quite frankly, really exciting stuff. There's stuff in there that's still mind-boggling, and the public, let alone our industry, is still trying to get their minds around things like social scoring and CBDCs and ESG and what that means for you and your future, that sort of stuff. Well, the ability for us to play this out and test ideas and concepts in that space is what we need. You can't test these concepts out in the real world. If I want to test it on balancing the objective for sustainability for trees or fish versus economic return, I can't test it on the fish supply. I'm going to kill fish and destroy forests. So there has to be other ways for me to be able to work in this area. So there's nothing wrong with these. These are all models that we've produced. Right? But there is something wrong with this picture in that they are static. And they're a point-in-time view of an organization. And what tends to happen is they're very silo-focused still, whether it's a cross-cutting value stream, whatever the case may be. All right? There's models and things that we produce in an organization that are static. And huge value, you still need to do that. We still do this. When we design the operating model to realizes a systems model, we still have to do it, all right? But my question to you is, once we've created them, how do we test the impact of this on the behavior of the entire ecosystem, on the behavior of the business? Yeah, I've got a little value stream down here, but there are massive unintended consequences that this value stream is going to cause right across your business and across your ecosystem. Oh, how do you test that? How do you know? Can you do that in a workshop? No. How do you do it if it's across multiple countries? How do you do it if it entails thousands of stakeholders? Like DevOps that brought automation to a process, you need some element of automation at this level. And you need to create games and gameplays and these sort of digital twins that would allow you to model these things and play them out to see their outcomes. Okay. Now, somebody said they hate 2x2s. Sorry. I'm a big fan of 2x2s because it brings together two spectrum lines, and that's how I can create meaning from insights. Okay? And so I'm going to spend a bit of time on this because we've built some interesting target operating model components out of this 2x2 model. And there's some important lessons I just want you to hang on to because I'm going to show you how to automate this. Okay? Top right is what we consider to be highly valuable but complex. And really only humans at the moment are able to deal with complexity. So that's a people problem. If I've got things, whatever those things might be, in the top right quadrant, I throw smart people at it, nothing else. Their job is to reduce complexity. So they will reduce it by bringing it down into the bottom right quadrant, understand the heuristics and the processes and how the business actually runs, or they will reduce it by moving it over to the top left, which is outsourcing. So legal services, if I'm in a business. I don't want to hire a whole bunch of lawyers. It's complex stuff, contract negotiation, all the rest of it. Flick it out to the top left quadrant. They can do it. It's not core to my business. But the process is to take stuff from that complex space into the complicated space on the bottom right and ultimately into the simple space by automating it and getting highly repeatable things occurring. Okay. All right. So what we want to do is I want to talk about symphony. Because what tends to happen is we look at the whole business as a whole, wicked problems. Where's my man with the wicked problems question? Somewhere here. There he is. We decompose it, but we have to recompose it. And often that doesn't happen. So let's decompose the problem. Here are some value streams. This is what the value streams all look like. And what? The point of systems thinking and complexity theory is we want to see how that now works in the context of the entire system. And how does that operate? So there's a symphony that needs to be created in order for us to do this. All right. Let's get into some demo mode here. So now what I'm going to do is I'm going to do a very light introduction of a very well-known model of competing objectives. I've got this on a video on my website. You can check it out if you want to. All right? And so there are two competing objectives here. There is the amount of fish in the sea, and there is the number of ships at sea so that my fishing village can survive economically. So I've got an economic driver, and I've got a sustainability driver. And so in the system dynamics world, we have to balance this. How do you create the correct balance in this environment? So you kind of build the dynamics of the system, and this is referred to as a stock and flow diagram or a system dynamics diagram. My view is that it is a digital twin if I connect it into the environment. Chat about that offline. All right? And I can actually run it. So I've got the means to execute and sort of see what happens. All right? Well, hold on, let me just switch this pause interval off. That's going to create some problems. All right, so now I'm at a point where I can actually see, well, what's the behavior of this business over time? There's some rules that I've baked in here. So over time, I can actually now see that, well, if I keep on releasing licenses for shipping to occur, I'm going to deplete my fish stock. And part of this exercise, especially when you've got a large group of people to work with, is you convert this into a game and you get multiple people to interact with this. Because there's one decision maker over here that's responsible for licenses. There's another decision maker over here that's building ships. There's another decision maker over here that's fishing, and there's a policy maker over here. So there are multiple parties that all have an influence on the system. And so what we want to do is we want to mimic that behavior. Don't worry, the model, this full model is probably about 4,000 variables. That's a lot bigger than what you see here. Okay. But there's some interesting things that you can do now. All right? How am I doing? Good. So I can say, well, all right, you'll have a look at the bottom here. I can track this back and I can sort of see, okay, well, what's happening over time? And I can start to mimic behavior and sort of see, all right, well, this is how things are moving around. How do I want to reduce that the impact on the fish? Well, what about if we reduce the normal catch per ship? So we reduce what they're allowed to catch. So you can see here, well, it slows it down a bit, but it's still on a downward curve. All right, but our profit can actually be reduced. Because now, look here, run 3 has reduced the profit because we've reduced the catch. Well, can we actually increase the number of ships that we release to the market? And suddenly you see my fish stock falling down again. Okay. So the ability for me to interact with different levers is limited. Bounded rationality, I think, might be the term. There's only so much that I can contain intellectually here in order to fiddle with the levers. The human brain has a maximum of 9 levers that you can run in parallel. What's the average? 3. Excel's rows and sheets, rows and columns. So the ability for us to contain multiple levers in our heads to understand the impact of those on a complex environment is diminished. Okay. All right, you're on to 5 minutes, I've got 14 here. Okay. And so what we have to do is we have to balance this. Okay? So we've got to create some element of balance. And so ultimately, we'll figure out through policy and we'll start to execute a run on the top of this. So eventually I can build the dynamics in that looks at the trend and I can create a balanced flow of the ships and fish stock on the side there. So there's some rules around how often I do it and what I must look for, but ultimately I've now created a balanced system. This is an example of competing objectives and how we can run with this. How does this apply to central banking? Okay, so this is a non-contagion model. Okay, it's very big. All right, it has other modules embedded in it. But what this thing does is mimic the behavior of a financial collapse in your economy and a run on the banks. And so how do we stop and prevent a run on the banks from occurring? Are there things that we can actually do? So all of the dynamics are coded in here, in this model at the bottom here. And we can play this out over time. Same story. I can now run this, and you can see, predominantly from the graph on the top left there's an activity that occurs. I'm going to create a fund, and over time, I've got enough funds to pay out a bank failure, and all's good. I've got sufficient time to deal with no banks failing. But what happens if I have one bank that fails? What happens if I rotate this and I move it to one bank? Okay, suddenly we've got an interesting story. There's a shift that occurs, and let me zoom into that on your top right there, top left. All right, so there's a shift that occurs. What happens if 3 banks fail? What happens if panic sets in, where we have to build in behavioral changes of people and how panic becomes a contagion? What happens if more banks start failing? And we can actually now start to play out, well, what's the scenario if let's say, 3 banks fail? How much additional reserves are we going to need to be able to bail the banks out at that level? What happens if it fails at a different point in time before the fund is actually established? And can we play with this model and see the impact on whether it occurs tomorrow or 5 or 6 months from now? What's the impact on my head count? All right, over here, I've got an impact on head count, and I can see the impact of what's occurring on my business. What about my process landscape? What's occurring at the process landscape? Same story. Now what I can do is I can connect all of this to a target operating model. So remember those 4 quadrants I told you about? Here they are. Here you've got complicated high-value processes. Here you've got complicated. Here you've got automated. Here you've got outsourced processes. So in understanding the processes, we know that there's certain behavior that occurs during a bank failure. And at a particular point in time, complicated processes become complex, which means that they come back up into the top right quadrant, which means I need to get my senior people, they can no longer manage the low-level processes, and I need to pull them up into the bank failure, and I need to supplement them at an organizational level with a team underneath that's more complicated. And so understanding the dynamics of how processes execute at my target operating model is extremely powerful. And now what I can do is I can connect that to my structure. So I can actually say, here's my normal headcount over here. What do I need during a bank failure versus not? And what it's doing is it's giving me a perception on the reserve of people that I need, plus how many consultants I'm going to need to bring in at a particular point in time during the bank failure, et cetera, et cetera. So you can see we've got the ability to take quite a high-level strategic model and bring it right down into operating model space. This is one area we experimented with, which should please you, but we decided it's not wise to build a system dynamics model of capabilities. But you can see here, we've actually created a capability called investment management, and through the projects and the investment in it, that capability is a stock. The more work I put into it, the value of it increases. Think of it like a bathtub, and it stores value. So its value is increasing. And so if I improve processes, people's skill, the data quality that I put in there, I'm actually making that stock more valuable. And so now what we do is we take this investment management capability, and for example, we'll drop it in the investment module, which is here. And there you'll see is the impact of the investment management capability on the investment turnaround of your investment module. So now you can actually make your capabilities real. And you can actually, based upon the maturity assessment, see how much return will I get from the financial markets department if they take the fund and they invest it with an excellent investment management capability. Now I can have a conversation with strategic decision makers. I can run scenarios. I can tweak policy. They've got a bit of a digital twin to experiment with. And we've done this with a bunch of different companies, but it really works well within the complexity space. I haven't got time to show you how to do that on an operating model level, but ultimately, I think for all of my AI people in the room, see if that one works. No, it doesn't. What you can do with this, and we're creating some interesting stuff in that space. So you can see your bottom bit is your system dynamics model. And if we run sufficient Monte Carlo simulations, I didn't show you Monte Carlo, okay, but basically I can get the machine to determine how many of those levers I must pull and which configuration must I pull them at in order to return a maximum profit and the maximum fish in my fish catchment area. So balancing my objectives. No longer worrying about the limitation of the ability for me to balance 9 objectives levers together. And so what we can do is I can run millions of scenarios to build what's called a synthetic data set. That synthetic data set creates data. So this world, we use structure to create data. In the AI world, you use data to create structure, so we complete the loop. And so what this means is that because of that structure, there's a synthetic set of millions of transactions that I've now created, which I can use to train an algorithm based upon the behavior of the system dynamics model. And then in future, there are decisions and insights that I can now get from that model. So looking at Annika's model that we had this morning, I was like, oh, that's it, look at that. It's got the beautiful dynamics and the creativity of defining that system, but I want to take that and I want to automate it here. And now suddenly the behavior of that entire ecosystem is actually running for me to actually play in it. All right. So lots of information to share with you, but hopefully that's given you a very, very small view into some of the dynamics that we play with. And this is where I want to challenge the enterprise design community. We're not getting in at the right level to have these type of conversations with the right people. You've all got that multidisciplinary skill to where you can bring all these things together. For some reason, we tend to be stuck down here in the quagmire of delivery or something. And so this discipline needs to get the visibility to be able to go in at a policy level and influence policy. And with these types of tools available, they can make what you do very powerful. It's not a static diagram that people kind of look at 1 minute, it's out of date the next. All right? It is living. They can ask questions of it. They can experiment with it. And they can do that all within a couple of workshops. Thank you.
Perfect. Thank you. We might have time for one question or reflection before we head on to the next, please.
Thank you. Very interesting. We have done some work on digital twins also, But the structure that you built, all the rules and the principles for this whole thing to be accurate is often a challenge. Where do you find the data? Is it true data that you have? What are the principles and the consequences of this and that and the other interacting? And how do you get that?
So, a great question, because one of the benefits of a digital twin is that I can actually plug into my live environment, all right? So we've traveled this road, and plugging into a live environment through process mining that brings the feedback data back in and allows us to connect to structure was the way that we would normally do it. But what we discovered was that the executives did not like connecting that level of performance data to their decisions. They preferred to operate in a slightly more abstract world. And so sitting up top here, dealing with the abstract nature of this digital twin was a lot more comfortable for decision makers than if it was connected to actual data. All right? We can do it, and we've done it, but it didn't have the benefits that we thought it would, because we can automate the entire loop and create a triple loop learning organization. We can actually bolt on DevOps, BizOps, and StratOps and allow you to actually experiment with your strategy and get feedback in much shorter loops. It's actually not what they're looking for. And so I think a time is coming where they'll start to ask for it, but it's not an easy sell. Yeah. Thank you. No.
There's sound. Thank you so much. That was beautiful. Very inspirational. Big hand of applause.